In the United States, 117 people die in car crashes every day. To make our cars safer, designers need to collect data to measure exactly what happens in the event of an accident. So, how do they create a highly sophisticated crash test dummy capable of precisely mimicking the human body? How do they do it? If it wasn't for the invention of the crash test dummy, it would be impossible for car manufacturers to test their designs. But creating a dummy which behaves in the same way as a human body is a surprisingly tough challenge. The very first test dummy was designed in 1949, but it wasn't until 1971 that General Motors developed the first standardized model, Hybrid 1. Up until the 1970s, most tests focused on seatbelt design. But by the 1980s, dummies were being used to test every possible type of crash. But even so, the problem of accurately modelling the body meant the use of human cadavers and animals was still widespread. So it was clear a new, more sophisticated generation of crash test dummies were necessary. This is First Technology Safety Systems, just outside Motor City, Detroit. They're the world's largest manufacturers of crash test dummies for the automotive and aircraft industries, and have been making dummies for over 40 years. Their aim is to produce a dummy with biofidelity, meaning it exactly replicates human characteristics. Their dimensions are based on 48 key body segments, and they cost $150,000 each. To create them, the company have had to find a way of modelling two different aspects of the human body: flesh and bone. Each body part begins as a steel mould. These are first cleaned, ready to be filled with a special type of vinyl. To ensure they're perfectly sealed, the joints are painted with a type of mastic. These moulds are then placed in an oven and heated at high temperature.
First, we take the mold and we put it in the oven for 40 minutes to preheat. Once it's preheat, it gets to a certain temperature, which is about 225 degrees.
Once at the right temperature, the mould is taken out of the oven and the liquid vinyl is poured into it. They have to get this just right so the thickness of the skin is perfect.
We'll put it back in the oven and cook it for 55 minutes until it cures.
Each mould needs to be baked for a different duration according to the body part being created. Getting this delicate process right is vital, or the vinyl won't be an accurate substitute for human flesh. Depending on the body part being created, some sections also use a vinyl plastisol foam to simulate the crash impact on soft tissue. This is injected into the moulds until it sets before being carefully removed from the armature. The body parts then pass to a team whose job it is to hand-fill holes left by the moulds and remove any excess vinyl. Once the individual body parts are complete, they're ready to be attached to the skeleton. The limbs are made from stainless steel, while 6 high-strength steel ribs replicate the rib cage. The neck and skull are created from lighter aluminium, while the lower spine is made from butyl rubber. With all the body components completed, the process of assembling the dummy can begin. The skeleton in this finished dummy will replicate the movement of 39 human joints, while areas of skin and tissue are precisely modelled by the vinyl plastisol. But a lifelike dummy is still just a dummy if it doesn't provide some clever information. Early dummies had to be attached to a computer by a network of cables. The problem was, these cables frequently interfered with the dummy's behaviour. So the latest designs have a built-in computer able to record up to 35,000 pieces of data in a 150 millisecond crash.
It's full of little strain gauges. When they're under stress, they flex a tiny little bit, and the strain gauges capture that.
Creating each of these gauges takes several weeks. Each dummy is typically fitted with 128 different sensors. These are able to measure forces on various areas of the body during a crash test. The next headache is calibrating them all. If the sensors aren't set up correctly, the dummy won't provide accurate information. So each dummy is put through a rigorous series of tests in this special lab. Here they test the parts of the body most commonly injured. In charge of the process is Jim Sylvester.
We're testing according to certain government specs that material or that part has to conform to. It has to have a certain force or a certain deflection in order to be passing test.
First, sensors designed to measure whiplash are calibrated. The head and neck are attached to this huge metal arm, and a piece of honeycomb aluminium is fitted to absorb the impact. When the arm is released, it smashes into the honeycomb, and the flex of the neck section is recorded by the computer. The sensors measuring frontal impacts are calibrated by subjecting the dummy to repeated strikes from a 50-pound weight. This is set to an exact height, so the force of the blow is constant. Other machines test sensors in the head and the flex of key skeletal joints. Thanks to data collected from this testing, the company are now also creating detailed computer models, allowing crash test simulations to be run entirely in software.
We've actually developed computer models that simulate these actual dummies that can be used so that the actual test isn't needed as much, but still very much rely on the physical measurements.
Once the dummies are tested and calibrated, they're ready for shipping to car and aircraft manufacturers around the world. And whilst these dummies might not be great conversationalists, their selfless work at the sharp end of car testing means that travelling by road is now safer than ever before.